Hi there. So this is just a video to hopefully get you through exercise 12.1, which and just a brief introduction to complex numbers. They were sort of invented originally by two Italian mathematicians. You can read about it here. They're incredibly important in engineering and in computer imagery, particularly in graphics and stuff like that, or writing computer graphics software, because I guess they're kind of numbers that can be in more than one dimension, as we'll see later on. Anyway, as an introduction here, so far you can read through this yourselves, actually, the notes here. But basically, complex numbers arose out of this kind of problem here, where you have the square root of -8, for example. So some guy came up with an idea like you can split that up into the square root of 8 times the square root of -1. And some guy came up with the idea of, well, let's just call this square root of -1 here I. And I guess that was the start of it. So in general, complex numbers kind of have two parts of them. So, and instead of calling it x equals, we call it z equals. So the two parts, a real part and an imaginary part. The real part is generally called a, so z equals a plus bi. The real part is called a and the imaginary part is called b. So as an example here, z equals 7 plus 2i. So the real part is 7 and the imaginary part is 2. And you can read through the other two examples yourselves. As a different type of example, how do you simplify the square root of -100? You first of all split up the square root of -100 into the square root of 100 times the square root of -1, and then work out the square root of 100 and replace the square root of -1 with I. And then to go on to actually solve an equation, so you bring across the plus 100, it becomes -100. Then we get the square root of both sides, so we're left with plus from minus square root of -100, and we already worked out here that's equal to 10i, so we end up with plus from minus 10i. And then some other little tricks here. So, well, if I is equal to the square root of -1, then I squared is equal to -1, because you squared to get rid of the square root. I cubed then will break up into I squared times I, and we know that I squared is equal to -1, so it ends up being -1i. Then I to the power of 4, which is kind of a useful one because you end up with I squared times I squared. That is -1 times -1. That is equal to 1. So I to the power of 4 is equal to 1. Why is that useful? Because let's say, for example, you want to work out what does I to the power of 18 simplify down to? Well, 4 into 18 goes 4 times, remainder 2. So you can split this up into I to the power of 16 times I to the power of 2. And that itself breaks down into I to the power of 4 to the power of 4, and we can replace that I to the power of 4 with 1. And then 1 to the power of anything is simply equal to 1. And then times that by -1, which is I squared, you end up with -1 is your answer. So I to the power of 18 is equal to -1. Another example here, I to the power of 29, same thing. 4 into 29 goes in 7 times. So you break this up into I to the power of 28 times I to the power of 1. And then follow along here, and hopefully you can see maybe how it ends up that I to the power of 29 is equal to I. Now, with that very quick introduction there, you can now go and try exercise 12.1. Just have a quick look here to see if it's doable. Let's have a quick look at the exercise here. So there's lots of examples there. You can read through them yourselves. That's nice enough. This one here just simply means, I think you just type square root of 32 into your calculator. I think you will get 4 root 2. So you can just use your calculator for that part. That's a nice question. And then on to the rest of it there. So then go a step further. You're going to be splitting all these guys up into the square root of 8 times the square root of -1. So the answer there is the square root of 8i. And then that's the same as the examples in the book. That's what we were talking about a second ago. 4 goes into 13 3 times. And then just gets fancier here. Try and work this out and simplify it down as much as you can and see, can you add it up? They probably would, most of them should add together, I think. And then a bit of messing about then on question 8. I think that's very doable. Let me know if you have a problem with it. Okay, thank you.